Welcome to Frost Sullivan's Growth Podcast. This series brings together key insights from our research, growth analyses, and thought leadership, highlighting the strategic imperatives shaping industries, technologies, and markets worldwide. In this episode, we focus on cloud infrastructure and platforms, distilling essential perspectives to help teams understand what is changing, why it matters, and how organizations can align strategy with emerging growth priorities.
Consider this simple truth. Cloud business solutions, as we knew them earlier, are under pressure to transform. For years, enterprises built on the assumption that general-purpose compute would scale infinitely. Need more power? Spin up more instances. Need storage? Expand capacity. But something has changed. Artificial intelligence, especially generative AI and agentic AI, have completely rewritten the rules. We're no longer dealing with predictable workloads. We're dealing with explosive demand for compute, real-time inference, and massive data flows. And suddenly, the cracks are visible. Latency matters more than ever. Cost per query is under scrutiny. Performance isn't just a feature, it's a competitive differentiator. And resilience, it's no longer optional. What's emerging is not just stress on current infrastructure, it's a fundamental mismatch between how cloud was designed and what it's now expected to deliver. So here's the real question. Are your organization's cloud architectures evolving fast enough to support tomorrow's AI-driven workload?
Now let's go deeper. Today, AI isn't just another workload, it's becoming the primary workload. That shift is transformation in itself. Cloud providers are no longer optimizing for generic applications. They're building for AI-native environments. That means infrastructure designed specifically for training models, running inference, and managing vector-based data. We're seeing the rise of inference-optimized architectures, vector databases built for semantic search, SLA-backed AI services, orchestration layers that prioritize AI workloads. And here's where it gets interesting. The economics of cloud are changing. It's no longer about cost per storage unit. It's about cost per inference, latency consistency, throughput. The providers who understand this shift and treat AI as a first-class workload will stand apart from other competitors.
Let's also talk about something organizations might overlook: networking. Because here's the reality. AI doesn't just consume compute, it consumes connectivity at an unprecedented scale. Inside modern data centers, distributed training workloads are driving massive east-to-west traffic. Training a large AI model? That's thousands of nodes communicating simultaneously. And traditional networking? It simply wasn't built for this. So what's changing? Cloud providers are investing heavily in ultra-low latency interconnects, deterministic network performance, high-bandwidth network fabrics, intelligent congestion control, advanced switching systems. Which leads to a critical question. Is your infrastructure strategy accounting for compute power, but underestimating the network that makes it usable?
Now let's move even deeper into the hardware layer. For years, cloud providers depended heavily on third-party GPUs. But that map model is starting to break. Why? Because demand for AI compute has exploded. Supply chains are tight, costs are volatile, and margins under pressure. So what are providers doing? They're going vertical. We're seeing a surge in custom silicon development, proprietary AI chips, hardware and software co-optimization, strategic semiconductor partnerships. This is about more than performance. It's about better. Control over cost, control over supply, control over innovation speed, and ultimately, control over differentiation.
Now let's shift from technology to geopolitical chaos. Because cloud is no longer just a technical decision. Governments around the world are tightening control over data residency, cross-border data flows, national security frameworks, and that's forcing a rethink of how and where infrastructure is built and hosted. We're seeing the rise of sovereign cloud models, where data stays within national borders, infrastructure aligns with local regulations, governance is transparent and auditable. This isn't just compliance, it's architecture shaped by jurisdiction, and it's driving the adoption of hybrid cloud strategies, multi-cloud deployments, region-specific edge configurations, because one cloud simply doesn't fit all anymore. Which brings us to a pivotal question. Is your cloud strategy designed for global scale along with local sovereignty?
Lastly, let's talk about a constraint that's absolutely critical: power. AI infrastructure is energy hungry, and not just slightly, exponentially. We're talking about higher power density per rack, massive cooling requirements, increasing pressure on electrical grids. And here's the problem. AI growth is moving faster than energy infrastructure can keep up. That's creating a new kind of bottleneck, not compute, not storage, but electricity itself. So providers are adapting fast, locking in long-term power agreements, investing in advanced cooling systems, designing high-density infrastructure, prioritizing energy-efficient silicon for. Because in the future, the question won't just be, can you scale? It will be, can you power that scale?
Finally, let's bring it all together. Cloud economics are changing, fast. The old provider model was simple: scale up, reduce cost, improve margins. But AI breaks that model. Now we're dealing with highly variable workloads, expensive compute resources, complex capacity planning, rising resilience costs, and suddenly efficiency matters more than ever. We're seeing a shift toward GPU utilization optimization, cost per token as a key metric, performance per dollar benchmarking, reserved capacity strategies. At the same time, enterprises are no longer relying on a single provider. They're embracing multi-cloud and hybrid cloud models, not just for flexibility, but for cost optimization, compliance alignment, performance tuning, healing. And managing all this manually? Nearly impossible. That's why we're also seeing the rise of autonomous cloud operations, systems that continuously optimize infrastructure in real time. Because in this new world, success isn't about having access to the cloud, it's about using it intelligently. So let's end with the most important question of all. Do you have the visibility, control, and strategic clarity to optimize cloud infrastructure investments in an AI-driven economy?
That's all for this episode of Frost & Sullivan's Growth Podcast. For deeper analysis, research insights, and strategic frameworks shaping future growth, explore our studies and resources at frost.com or reach out to our team at hello@frost.com. We'll be back soon with more perspectives to help you stay clear-headed and growth-ready.